Hello everyone, welcome back to our YouTube channel. In today's video, we are going to discuss about why there should be no multicollinearity when we are building a model. We'll try to understand how does multicollinearity impact the performance, as well how does it change the interpretation. So without any further delay, let's get started. So first of all, let's try to understand what is multicollinearity. Multicollinearity means that there is a high correlation between independent variables. No multicollinearity means that there should not be high correlation between the independent variables. So let's try to understand this with an example. So in this equation, as you can see, we have y is equals to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3, and the adjusted R square is 0.84. What does it mean? Adjusted R square is 0.84 means that we are able to explain 84% of the behavior in y by using x1, x2, and x3. And x1, x2, and x3 is our independent variable. Now, let's say that I want to understand how much behavior in x1 I can explain by leveraging x2 and x3. So what to do? Let us again build a regression model. So now we have building a regression model on x1 by using x2 and x3 as a independent variable, and let's say our adjusted R square is 0.9. So what does it show? That 97% of the behavior in x1 can be collectively explained by using x2 as well as x3. Now the question is, do we need x1 when we are building model, when we are trying to predict y? We don't, because x2 and x3 can explain the part what x1 is explaining, right? So we don't need x. Similarly, we can also build a model on x2 by using x1 and x3, and let's say here the adjusted R square is 34, 0.34, which is 34%. Now, do we need x2? Yes, we do need x2, because we are not able to explain significant portion of x2 by leveraging x1 and x3, right? So in this example, when we are going to build a model, we will not use x1, because x1 can collectively explained by leveraging x2 and x3. Now the question is, why we are even doing it? Is there any impact on the performance? No, there is no impact upon the performance, because if you see what x1 is doing, the behavior of x1 is collectively explained by x2 and x3. So it's not like we are removing x1 and x1 is adding the noise. We are not doing that. We are just making our model simpler, because it changes the interpretation. So let's take an example. Let's say you have built the model where you have used, let's say, 20 to 25 independent variables. Now someone asks you to explain it. The explanation becomes much more complicated as you increase the number of independent. But if you are keeping your model simpler, it means very less number of variables. It makes your model much more simpler to explain it to the stakeholders, to explain it to the business, and also to understand how these factors impact your dependent variable. So this is one of a good practice. That's why you can say that there's also one of the assumption in linear regression that there should be no multicollinearity, and it is a very good practice that data scientists follows across it when they are building the solution. So hopefully you'll be able to understand the importance of no multicollinearity and how it helps. That's all for this video. Until then, happy learning and good day, guys.